So without further ado or delay, I'm going to start the presentation that I recited a little bit about from like preserving diversity to bridging linguistic frontiers. And this will be sharing my experience in general about NLP innovation to empower and like still preserve like African languages. What we've overcome as challenge and like the progresses and also the promising features, like what I think could be the next step, what I would like to be working on or to have or to etc. etc. So by starting, I'll first of all focus on the lack of integration because we're talking about diversity. So the first challenge to that is the lack of integration, for instance. So if we look at the first chart here, we can see that this is like a ratio of living language in the world that are not African and living language in the world that are African. And yes, all combined makes a huge part of it, but we can see that African language alone represent at least like 31% or let's say 32% of it, which is a very huge and not non-negligible portion. But when we look at technologies that exist, let me say for instance a voice assistant like Siri, Alexa, Cortana, there's no African languages in there. On the translate aspect, there are more efforts, some more effort. For instance, on Google Translate, we have about, I think, maybe 50 or 40. I don't know exactly the real number, but there has also been a recent effort to like augment the Google Translate API and interface with 20 or 24 new African languages. On Deep Translator, which is also a very good translation service, there is none. And beyond this, we have just quite a few, I think one or two, technically. So there's already a lack of integration of African languages in everything that exists as current systems. And we saw these as on the voice assistant and voice on like test data. The second challenge still for like diversity and integration will be what I call the lack of representation. So these data I got them from like Hugging Face, which is a pretty known repository now in the area we are in. And on the left, we can see here that at the moment we only have what mainly three entirely Afrocentric multilingual portrayal language model that are acronymed as MPLMs here. So there's AfriBeta, which is covering 11 languages, AfroLM, one of the language models that I worked on with my colleagues, and AfrixLMA that are working on that are focusing on 17 African languages. So you can see that if the max being 23 is still very far away from the more than 2,000 language that we have across the continent. Now, what about existing multi-language actually in general? So the black here shows what we have as existing multilingual virtual language model in general across all languages. And the red shows the ones that are not even Afrocentric, but that are just integrating some African languages. It can be maybe one, it can be two, it can be three, and so on. And they represent only 1% in the big crowd of existing language models, which are nowadays powering a lot of downstream applications, startups, scientific discoveries, and so on. So I also wanted to focus on data sets because what we build are mainly based on data. Like data is a fuel and a very important fuel to developing those methods, those models. So we have also the same trend, like about existing data set. We have very few covering or like and focusing entirely on African languages. And if we look at also the percentage of like CL computational linguistic publications, we also see that there's a very small ratio of publication that are focusing on African languages, whether it's entirely on them or whether it's like other language and then maybe one or two African languages in. So how do we manage, how do we take from there? Because we want to not only preserve those languages, but also make language technology diverse by also being more open, more adapted to more languages. So as I was talking about data, the next thing obviously is about like starting from trying to build more data sets. which are some efforts that I have been involved in, and also some of my friends and the many communities as well are working on it. So, for instance, for the first one, the FFR is the first data set that I created for my language, my native language form, which is a machine translation data set. And it had been initially published at iClear 2020, then ACL, and then there've been like many versions of it. And it's also just maybe a little bit of like inspirational story because it shows that one can start actually from, let's say, nothing to actually build something. So one of the version of the data set were entirely based on crowdsourcing, like creating a simple form, a Google form, and then sharing with friends, with like acknowledge acquaintances to be like, oh, hey, what are the 5 or 10 sentences that you use daily, knowing that they are coming probably from Benin, and then like myself in a few language friend, we tried that and it actually allowed us to create up to think 25,000 pairs of sentences, both in phone and French. It's not huge if we consider like how much data we should have. It's already initiative, and that's what fueled the actually my first research paper, the FFR, which was about phone French neural machine translation. And then from there, we also have obviously many of the different tasks, like we have like any entity recognitions here we have two other versions. The first one was focusing on like 10 African languages that are like shared across the language families in Africa. And then the second version included more languages, for instance, Fon, where I also co-led the effort with some other friends to be able to not only create sounds, but also translate sentences and then like perform human annotations and making sure that those are high quality. And then there are many others examples like Massacre News, which is about news topic classification, POS, part of speech, sentiment analysis using movies, that's Niger Senti, and many others, Bible, TTS, and so on. So when the data has been created now, how can we make sure that they are discoverable? Because first of all, you can't use something that does not exist. Now, the second stage is you can't use something that you don't know that exists, right? Because if you don't know if that exists, you don't know technically where to find it. So with Chris, the idea is actually originated from him. The idea we've worked on Landfreaker, which we call a home for language resources. And it actually put together everything or almost of everything. It talks about the software, it talks about tools, it talks about videos of someone like teaching maybe Yoruba to kids, or videos someone's studying or like teaching Afar, like a very low resource language, all those type of things. But then as we were going, we also wanted to make it a place where not only researchers come, like for instance, for papers, for models, all those type of things, but also like other people from other backgrounds, like linguists, like data annotators or data creators. Those people come together in that same environment to be able to create more resources and like to promote them like further. So for instance, with Landfreaker, one can easily find a data set in Afar in a very low resource language, which we would not have found through a search like on Google search or Google search, for instance. So now that we have the data, now that we've managed to have something to start with, how can we move on to the modeling aspect? How can we build systems, right? So the first thing is obviously leveraging what already exists. So the idea about language models that are pre-trained today is like we can have like train on massively huge data sets on English or like Western languages, and then maybe we can then adapt, fine tune them on like downstream tasks, right? So one of the first of such initiative also done with Chris was what we call MMT Africa. I think by the time we were doing it, it was the first multilingual translation, machine translation system for African languages, where we focus on the translation from like from many to many, right? Like it can go from one language, go to another language, and come back to another language, all this type of thing. And we focus on six African languages as a start. So we tried many things. The first thing obviously is like to fine tune to on the translation data set that we have. The second one is including back translation because back translation empirically has been shown to improve to bring more, let me say, um, to improve the performance of the machine translation systems. So, for instance, if I say, um, je m'appelle Bonaventure, then it will be translated as, oh, my name is Bonaventure, right? But then if we take that French English translation and translate it back in French, we have, oh, maybe mon nom est Bonaventure. So it's the same idea, but expressed in different ways. So not only it increases like the size of the data set, but it also allows to have more variations of more ways of saying the same thing, which is mainly like inherited like in human language and communication. And then after we talked about uh, back translation and reconstruction, where we added the reconstruction objective, which is technically we have a sentence, then we corrupt the sentence, and then we want to make sure the model recovers it back. Is a little bit, I mean, it's definitely not like that, but you can think in the area of like LLMs, you might think of something close to a mask like language modeling objective where we have an initial sentence, then we mask some position, and then we want the model to be able to recover them correctly, to be able to guess those words that have been masked. It's not the same thing, but it's just to give an intuitive idea about what it's trying to do. So in the overall, we found that working on working with back translation and back translation and reconstruction, we noticed two main trends. The the blue is the base, the orange is the back translation, and the green is like the BT. So anywhere where we have, for instance, here we focus on Fon, Igbo, English, French. So two African and two Western, mainly also serving as pivot language. So everywhere where we have four at the end, we notice that the back translation performed better. But anywhere where, for instance, we had Igbo at the end, we notice that the back translation and reconstruction performs better. So the idea behind that, I mean, one of the conclusions that we came is if we want to improve the performance of a system on a downstream task, yes, it's okay. We can have things like back translation and everything, but ideally we can really enhance the performance of that model by having that language on the pre-training set. So the main difference between Fon and Igbo here, for instance, is that on the MT5, which is the base model that we use, the model was pre-trained on Igbo tests. So it was able to do not only better on like back translation, but also better on reconstruction. Back translation here was helpful because technically with that schema, we obtain more data and like more contextual like informations and more variety of information as opposed to the base where we just took the initial data set that we have and then just punched it. And generalizing our findings to the Flores data set, we found that we got a lot of like improvement gain, for instance, plus 0.58 sentence speed blue for Swahili and more than 19 plus from French to Hausa and many others. So it varies between that range, but is it we are showing that those things have promises. And you can actually look at the QR code, I mean, scan the QR code and have more details about the result analysis and everything of the paper over there. So there have been many other works as well working on the same trend. For instance, Massacre, where we leverage initially, we created not only an NER data set for African languages, but we also leverage existing pre-trained multilingual pre-trained model like XLMR, MBERT, all those type of things. And there's also Massacre POS for part of speech tagging, Massacre News for news topic classification. One interesting thing we've also done was for the second version of the data set, of the master kernel data set, we work on understanding what features actually play a key role in improving that performance on downstream tasks if we are using pre-trained language models. So we found out that obviously the transfer language data set matters. The geographic distance, the phonological distance also matters. Like if I want to work on, for instance, phone, and maybe I don't have enough data on phone, but I have maybe a data set of Ewe which is spoken in Togo, which is like geographically close to Benin, where phone is originated from. Ewe improves a lot the performance on downstream tasks of phone, and is also the same thing for many other languages. So they've been understand that study not only linguistically but also morphologically and also from like a model perspective to show what one should maybe focus on when we want to improve, want to take the maximum from the transfer learning approaches. And obviously, there's also multitask learning where we have very few data about one language, about one task, for instance, but then we have a lot of data about the other tasks, how we put all together. And these study also showed that we did this study on two tasks, um, NER and part of switch tagging, POS. And what it shows is that both of them are actually being useful to one another, to each other in the downstream performance task. And you can also, it's already online on archive, and then like we led extensive studies over there to also look at the type of the way you merge the representation from the shared encoders, how does that affect the performance on the downstream task, and different approaches as well, all those type of things. So we go next then like to how many data we need actually to perform well in transfer learning setting, because I've been talking about transfer learning setting, but what is the minimum amount of data that we need to actually be able to have a given to pass a given threshold, right? This is what we studied in our NACO paper that was presented, I think, in 2022, that we called A Few Translation Go a Long Way, leveraging pre-trained models for African news translation. So first there we created a data set that we call MAFON that was combining both Franco and Anglo news data set. Obviously that we translated after. So for instance, for phone, we have initially it in French, then we work with language to translate it into the native language, which is phone, and many others. So those and English, French language, they serve more as pivot language, right? So obviously, so we created the first data set. We evaluated two different, um, let me say, tasks, which is the continual pre-training and the many-to-many translation. And we have our data across different domains, and we try to see which domain or like how does the data from a specific domain influences the result on the downstream task that we want to have. So the first thing is, should we actually do zero shots or should we actually fine tune before actually evaluating? And what we can see from the figures is we should actually fine tune because um row like M2M 100 about zero shots. If we focus, first of all, it did not contain most of the languages. But if we look, for instance, at Wolof right here, we can see that the blue is 1.3. But then if we look at the same M2M 100 after fine tuning, we can see that the blue score is 12. So there's a huge bump. We also observe the same thing in both directions. So here, for instance, we have from French to the native languages Afrikaans as same as English, but we also have like from like the languages to back to the Western, which are French and English here. And across both metrics like blue and character F, we observe the same thing. So pre-training, fine-tuning actually helps before the evaluation. Now, what about domain shift analysis? Like, what about combining many domains together? Because as you remember here, I said we put together data from two different domains, the religious domain and the news domain. So how does, and don't forget the target is to improve African news translation. So actually here, how does religious data is able to help on the news domain targets, tasks that we want to achieve? So what we can see first here is that when we train the model on religious data, and then we want to like want to evaluate them or maybe further fine tune on let me say news data set, it performs relatively not well at all. Like that's mainly what we are seeing across those two different figures. But then when is the opposite? Like when you pre-train on maybe you do a continual fine-tuning on religious and then you evaluate on religious, the performance is boosted. So it led us to so that to conclude that we have a strong domain bias and that those models that have been initially pre-trained on religious data have not been able to actually extend the knowledge and translate well news data because of exactly that strong bias. And all models actually perform worse on news data than on the religious data than as mentioned. So how do we actually can use that at our advantage and do better? So we want to see how can we adapt to domain shift and how much data we need to in a target domain because that's where the application we are focused on is and is the performance on that specific application that we want to improve. And here I put quoting well because well is subjective. What is well, what is a good performance for me might not be a good performance for another researcher or someone else. So it's very subjective. So here, what we've tried to do was performing some domain adaptation results. Um, experiments, sorry. Here I'm just presenting the results. So we performed some domain adaptation with experiment, and then here we have the result. So what we can see is that mainly doing that actually help. Like domain shift adaptation helps even if like the result is very marginal. So for instance, what we can see, like if we have a religious, we train, for instance, on like both data combined, then we have a blue score, for instance, of like 10.01. If we train on religious, and then evaluated on news, then we have more or less the same thing in other languages or like the majority of languages that decrease. So for instance, for Luo, what we have no for Luganda, I think what we have here is a blue of 21.1 and then a decrease to 20.6. It's not huge, but there's a decrease. But when then we do the domain shift adaptation, we observe, if not huge, because for here, for instance, we left 10.5 to 11.5 blue, like that's a 1 point. And or here we left 20.6 to 20.6 to 22.4 blue score on. So it varies different, depending on the language. But in general, it helps even if it's a small, very small like adaptation and skill. So that is the main thing. So the conclusion that came from it is we actually we don't need much of data like extensive or a lot because the religious size compared to the religious size what we the performance on the downstream task after we did the domain adaptation was not that much huge. It was very marginal. So the conclusion from that is we actually need instead more qualitative data. I say more to focus on the quantity and qualitative to focus on the quality of the data set on the target domain. That's the way we could actually improve the result on the and the performance on the downstream task on the target domain where we want to perform the evaluation. So then what about what do we call good and high quality data and actually how does it impact? So here the idea is to see how minimum of how a minimum, I mean how small of the data we need to actually perform better than the baseline. So here the baseline is a bilingual transformer that we train on those pairs of languages. So English and Swahili, English and Igbo, French and Bambara. And what we're seeing in most of the cases is as small as a 2.5 thousand languages. So like 2,500 languages. We observe the same thing on the first figure. On the second figure is also very similar. On the third is, I mean, more or less the same. It's 5 years. We have a 1K threshold, but that's it anyway. So it shows that's actually where the title came from, a few thousand translation. So with a few thousand, and which are not only high quality, but also good, I mean, high and good quality. But on the target domain like data are actually enough to match a baseline performance. Now, what is the baseline? It depends on the task and it depends on how we want to approach the problem. But here, our baseline was a bilingual transformer trained on on those pairs of languages. So that is it in general. So we found out that even small and high quality of data in the target domain is actually very, very helpful, right? It's very, very helpful. So then what if I will now try to think I'm approaching 30 minutes. I will now try to move to a case where I'm like, okay, the main ideology is to have a lot of data in the Western languages and then pre-train on them and then like have to fine tune. But what if actually we want to start from scratch and we have a lot of constraints, not only data wise, but also um, computationally wise. So how do we use the small data and a very constrained setup of computational resources that we have to actually build something that is not only good, a model that performs well, but is also robust to many things like noise and generalized as well. So this is where um, the idea of like using epistemic uncertainty, active learning, and combining and apply to language models or like African language tasks, NLP tasks in general came in. And then we have the first paper that we call AfroLem, except active learning based multi-language pre-trained model that we build on 23 language. And briefly, about some statistics is those are the different languages there our data covered. Obviously, they are more than that because we covered 23 of them, but then you can see the distribution is not even, is very like skewed and very imbalanced. Not skewed, very imbalanced. For instance, if we look at, for instance, Ewe, Tswana, Fon compared to things like Amharic, Luganda, or even like Kosa, we can see that there's a very big disproportion. But then how actually we have a data set like this, but we still maybe do as much as we can well on like languages with font, for instance. So the next one, I'm going to talk quickly about active learning that are acronym to you as AIR and the benefit. So active learning, I usually define it in literature is also defined as a kind of like semi-supervised learning algorithm where one is training a, let me say an agent. It looks like an agent or a model that learns to optimize its performance by knowing which example to pick in a pool of unlabeled data such that it maximizes its performance and optimizes its parameters. If it hasn't been it hasn't been a lot explored in the NLP community, but the very few works that explored it showed that with like less than 50% of labeled data, or some even showed that with only 20% of label sampled, we can achieve high accuracy around 80 or 90 or 99 of accuracy. And this is actually a very interesting concept and is very crucial in the context of African NLP where data is scarce, is like we cannot afford having like billions, trillions size data set on those languages. So overall, this is the architecture of the framework where we have the different model, the different languages, and then like we evenly um, split them across the training set, and then everything else is is kept at head out data set, right? And then we use the training set to train the from scratch the active learning, the model in at each active learning round. Now, when this model has been performed, this is where actually where we have the word self, because usually what happens is like we would maybe do some generation and then have a proxy model that behaves here more or less as a kind of, I don't know, classifier on the of the downstream task. So maybe here it could be like NER that will actually allow us to evaluate the different prompts. But then it turns out that the highest bit we have was maybe Afrexelema, which was covering only 17 languages. And we did not want to leave away or aside the six remaining languages. So that's where we now use the model itself that was trained in the current round to be able then to generate to generate new sentences given some prompt. And then given the new sequence generated, we have some filtering methods. So for instance, we use simple things like the word error rate to make sure that the sentence that we generated and the sentence, the prompts, the original sentence are not so similar in some sense. And then these are now added to the new data set of the language, and then like we restart the process from scratch for as many as rounds as we want. But I think in this world we focus on like three main rounds. So we have the experiment on NER, on text classification and sentiment analysis, which here we consider as all the experiment out of distribution experiment, because the data that was used to build AfroLM was mainly news data. Was mainly news data. So we moved to another domain, which for us was a little bit of a way of testing the generalization capabilities of the model. So what we can see here is that in average, AfroLM, the large version, of course, which has as many as parameters as AfriBeta large and XLMR base, we found out that the model performs better than all other alternatives, which is AfriBeta large, mbed, and XLMR base. And if we focus on mbed and XLMR base, they've been trained on like terabytes of data, as I've written here. AfriBeta has been trained on like almost 1 gig, and ours has been trained on even less data, but still outperform all other models that are currently on this table. We extended it to the second version of the master kernel. Like here, we did not evaluate on the entire language data set, but we only focused on languages that were not in this table, so that were not in the first version. And what we can see is also that in general, our model with the active learning approach perform better than mbed, etc., and everything else. Moving on to the test classification, we can see that the results are very competitive in the way that if we compare the number of language covered, the size of the data set used in everything, uh, our model performs similarly to AfriBeta. So the competition, the performance is very competitive with um, a very fewer number of parameters and also like smaller data set. And on the out of domain sentiment analysis performances, we can see that by far our model also does better compared to AfroLM without active learning and AfriBeta large. That allowed us to say that AfroLM actually generalized better in out of distribution settings. So we then oh, I was a little bit too fast. So in general, we have that our self-active learning approach is very data efficient, high performing. It outperformed state-of-the-art models like AfriBeta, mbed, etc. on various African NLP downstream tasks, and it also generalized better across domains. But then It means that we can build very powerful AI models that are data centric and very efficient. So when we are talking about data centric, very efficient, and various domains, how does this perform if we move from text domain to speech? Well, here we are focusing on like ASL, which is some sense. The output is also some text, but in general, how does a context where how does it work if we leave the context text to maybe, for instance, speech to text? So that's the same thing that we had explored in this work, adapting like ASR model to low research clinical speech using epistemic uncertainty-based data selection. So it's a little bit of rephrasing, not to say the same thing, and is being highly inspired from the Afro model I just presented, where we are basically doing the same thing, but here like the input is just speech, and then we have the word error rate. Now, to be able to quantify the uncertainty or the prediction, what we've used are like probabilistic Bayesian methods like MC dropout, and we've done that on the prediction that have been generated. And that's technically how we've built the system. And this work actually, we compared it against many state of the art. So, for instance, models, obviously. So we have, for instance, Web2Vec, XLSR, like the best one. We have Hubert, we have Nemo, and we recently added, sorry, I didn't update this slide. We recently added Wave LM, which is also similar and gives like similar performance to Hubert, at least on a general domain. So what we can see is that our approach, especially if we use the epistemic uncertainty-based approach, we outperform all everything else, like the baseline here, which is just take the data set, fine tune on it, and evaluate. So our approach like allowed us to perform way better in average and definitely across many other domains. And it will be surprising to know that we've achieved it by using at least 50% less data than the original data set. So we really constrain ourselves to the situation where we have very limited data sources, and how are we using it like the most efficiently. So that shows that obviously across models and across domains, our approach is working. But then what about data set? Maybe it's just the data set that we also introduce, right? So we then focus on three other data sets. So this is SAUTI-DB is about sentiment analysis. This is about medical speech, where we actually took data and like have like transcriptions of like medical transcriptions, things like that. And then we use also a very commonly non-second voice. We use train plus alpha augmentation, where alpha here, for instance, is a very small number. That means that we start by training, let's say, with maybe 30% of the data, initial overall data that we have, and then maybe we augment maybe like 5 or 10%, depending on the size of the data set. This is dynamically adjusted. So at the end of the day, you end up using 35 or 40% less data. And what we can see if we compare to the baseline is that there's a huge difference. So for instance, here we have 50% of water rate, and here we have only 12%, and so on. So these external analysis allow us to say, okay, it's not only about the data set that we also created, but it does not work only the data set that we create, it also works like way beyond. And as I was telling you, we were focusing in this paper, we used the AFRI speech data set, which is a clinical speech data set of like 200 hours that are covering a lot of accents. I think more than also 200 or plus accent, language and accent. So we define what we call the UWR, which is uncertainty word error rate, to be able to quantify how better our model is becoming across the different like adaptation or active learning rounds. So what happened is as we evolve, we can see, for instance, here on the clinical domain, that using our approach, its uncertainty weather rate on the top 10 accent has been completely decreasing. Obviously, here it's increased, which brought us to think, oh, okay, maybe there's a trade-off between how many adaptation round, or maybe and also how many maybe top K samples you actually select for the next active learning round. And here we also have the same observation when we combine both the clinical domain and the general domain. So overall, like our approach is very viable, efficient, and helps to build like models that not only generalize across models, methods, sorry, that not only generalize across across models, but also across data sets and across domains. And in those domains, in those data sets, we have a huge scarcity problem obtaining the training samples. And it also suggests that our models also learn because as we are going, we can see that the uncertainty, whatever it is, decreasing, which is the whole purpose of using this epistemic uncertainty to increase and the modern knowledge about those specific samples. It also induces some type of diversity in so that we don't focus only on the sample where the model has been initially or maybe after very few rounds already confident about. We want to focus on where the model is not strong enough and improve those different areas, improving therefore the whole generalization capability of the model. And this is also very informative and suits low resource language settings. So I think I'm a little bit closer. I'll have just 5 minutes and finish. I want us like to focus on creating more resources for African languages. More resources I mean about it can be keyboard, it can be software, it can be models, it can be anything, research papers, all those type of things. And we can engage in more community effort because it takes a lot to build a village, right? And all these things I've done are not necessarily on my own, and they are definitely not on my own. I've been able to work with collaborators. I told you how we include everybody, even linguists, in the picture so that it is actually becomes a community effort where every specific role plays a key role to the bigger picture, which is empowering and creating system that can actually understand like resources that are language that are left behind. And obviously also lead some more research projects to increase the representation of like people speaking those languages and from the African continent at top AI and NLP conferences, and obviously build and scale AI techniques specifically to African languages. So yeah, moving next, I hope everything that we've talked about that we've built will be able to be put into a system where we can actually be like, with our kids, we can actually maybe have an African version of like on Alexa, for instance, and then we can be giving orders and then it will be executing and then we could like interact with it. Kids would interact with it. That would be also a way of like preserving and like transmitting those like language values, for instance. And it goes by saying, obviously, what I say includes not only voice assistant, but also like translator. I also talked about keyboard because if you have those systems, especially text-based system, you have to be able to have a way of like imputing the sentences. And on the research side, we need to have more research scholars, young people passionate by challenge and innovation. That's only how we could actually put this ahead. Not everybody has to be researchers, so maybe they're going to be entrepreneurs who are taking these models that we are building and then like translating them into business ideas, all those type of things. So everyone has her role to play into these that are called my African dream and vision. And yeah, so that's mainly about it. I think we have, I don't know, I guess I can say 5 minutes or more. I don't know. But yeah, from now on we can take questions and like have discussion and move ahead.